Hello guys, welcome back to our channel. In today's tutorial, we'll walk you through how to set up a BLDC motor control circuit using RS485 communication, including how to connect and configure a BLDC motor controller with an RS485 to USB converter for seamless PC-based motor control. Let's get started. For this setup, you will need the following components. Among these components, the brushless DC motor requires the electronic controller to regulate its speed and direction. The 24-volt DC switching power supply is used to power the motor and controller, while the converter is intended to bridge communication between the controller and PC, which has dedicated BLDC control software installed, responsible for sending speed commands via RS485. This control system allows precise speed adjustments without manual potentiometer tuning. Now let's wire up the system correctly as per the wiring diagram provided. Connect the DC power supply to the designated terminals on the controller. Connect the BLDC motor to the controller. Ensure the motor's three-phase wires are properly connected to the controller. And connect the Hall sensor to the appropriate pins on the controller should your BLDC motor has a built-in Hall sensor. Wire the RS485 converter to the controller's RS485 ports. Before proceeding, configure the BLDC controller with the RV terminal turned off. Since we're using RS485 for speed control, we don't need manual adjustment. And set the two dip switches SW1 and SW2 to off by toggling both switches up. Double-check the polarity between the RS485 converter and the controller to avoid communication errors, with A to A+, B to B-. Then power on the system and plug the RS485 converter into your PC's USB port. Now let's configure the BLDC control software. Ensure your PC has the control tool installed correctly beforehand. Navigate to COM setting, then click Connect. The software auto-detects the COM port and baud rate. Upon successful connection, the software will start reading parameters. Once the reading is complete, this signifies the BLDC motor controller is successfully connected to your PC for RS485 communication. If connection fails, verify the port in Device Manager and confirm the controller's address. Under Parameter Setting, configure PN14 and PN15 to 2. PN14 represents the data channel, and PN15 represents the control channel. Setting these two channels to 2 indicates the selection of the Modbus communication protocol. Setting PN14 to 2 uses the SV analog input as the data source, while setting PN15 to 2 uses the I/O switch as the control source. Continuing, we need to set PN58, which controls the speed and direction of the BLDC motor. From the parameter description, we understand that the parameter setting for motor speed ranges from 0 to 65535, and the settings take immediate effect, with RS485 responsible for issuing commands to data A. For instance, if you want the motor to run clockwise at 300 RPM, input 300 in the new value column, then click Write Param to execute the command. Note that positive values indicate clockwise rotation, with 300 representing the speed. You can monitor real-time data and faults by clicking on the Device Information tab. For example, you can monitor real-time speed under PN137 speed. If not visible, refresh the data. And what about reverse rotation? To reverse the motor, you need to subtract the desired speed from the maximum value and enter the result into the system. Note that negative values indicate counterclockwise rotation. You can see that once we input the calculated result, the system will read the actual RPM and display it in PN58 as 300. Similarly, to run the motor in reverse at 1000 RPM, follow the same calculation step and write in the result. To be specific, subtracting 1000 from 65535 gives 64535. Enter this number, click on Write Param, and the system will command the motor to run oppositely at 1000 RPM. And to run the motor forward, simply entering 1000 will do. PN68 and PN69 can be used to set the speed range, with PN68 being max speed while PN69 being min speed. The default speed range in our case falls within 200 and 3500 RPM. It's crucial to note that any out-of-range values will default to the limits. For example, let's try extreme values like 104,000 RPM to observe the motor response. For the lower speed, the motor will remain running at the minimum speed of 200 RPM. If our statement is not convincing, you can verify this in the system information where PN137 speed displays the real-time speed as 200 rather than 100 as shown in data A. Likewise, since 4000 goes out of range, the motor will default to the maximum speed of 3500 RPM.
And when data A is set to 0, the motor will stop. And that's it. This concludes our demonstration on the RS485 based BLDC motor controller circuit. By leveraging this technology, you can achieve precise and seamless control of your BLDC motor system in automation, robotics, and industrial applications.